that. So yeah, first of all, a big thank you to all of you for attending my session, because I think it is really amazing to see many people just going after work and then now have another 1 hour to learn some new stuff about your favorite product like Microsoft SQL Server. And excuse me, I was speaking the whole day because I'm doing 2 weeks workshop now. It's a little bit exhausting. So what I'm doing is I'm talking about time series data with Microsoft SQL Server. If you're interested in the slide deck and in the demos and all that, you can download it here. Be aware of the uppercases. So timelines, it must be in the correct writing. So timelines with an upper T. Feel free to ask any question. Brian is watching the chat, so if you want to have a question about why we are doing that, feel free to ask. And we're going to see whether we do it in the session or later on. Okay, so now we go for it. And I think, yeah, have fun. We will see a few slide decks, but most of it will be demos. So this is me, just only a few words about me. Forget about the commercial thing on the left side. This is when I was young and I needed the money. And the most important thing for you here is my email address. And the email address, this is a true and real email address. So if you have any more question, maybe too shy to ask here, or you don't have the time to ask, just drop me an email. I promise to answer every single question about the current session, or if you have any questions about SQL Server, only SQL Server on-prem, and then you can just drop me an email. I would be happy to assist here to help you. So this is our agenda. It's very simple. First of all, we need to understand what time series are. So I heard that this is a Fabric user group. Fabric? Oh, I say, well, Fabric. Why do they want to have me? Because Fabric has all the cool stuff, because Fabric is more for data warehouses. It's more like a data warehouse system. And I was thinking about what the heck? Why do you want to have me, which I'm an old guy, old stuff like SQL Server on-prem. And because time series is a very familiar thing in data warehouses since ever data warehouses are existing. So we need to talk a little bit about time series. We're going to go very quick about that. And then I want to point to what makes time series so special from another databases. For example, why is Postgres creating a known extension just only for time series? Or why do we have dedicated systems for time series? So what relational database systems are available for time series? The big question. And what techniques can be used when we are working with Microsoft SQL Server for a time series? Because, and this is what I can tell you in advance, is since SQL 2022, we have some big improvements when it comes to time series. And one of the most important things for you to understand is how can we query time series data? How did we do it before SQL 2022? Because I think lots of customers will have 2019. And what has been improved in SQL 2022, and what makes 2022 better than the previous SQL Server versions. So here becomes, what are time series? So I think most of you know what time series is when it comes to data warehouse. Time series data is a set of values organized in the order of which they occur and they arrive for processing. That could be data queues, that could be stock prices, telemetry data from sensors, or what all of you, if you're an admin, know, it could be performance metrics. So time series is typical, and that's one of the special things here. Time series data is typically written once and rarely, if ever, is updated. So mostly it's that we throwing them in, and that's in the line, and then we want to have the evaluation from it. Time series is often used for historical comparison. Yeah, for me, for example, if you have something like, let me show you something. I'm a brand new owner since 1 year of a so-called voltaic system on my rooftop. And what I do every single time when the sun is shining, I'm just going into the portal, and in the portal I can see what is actually producing. You can see here, these are real-time values, and all these values are stored in a time series database. For example, if I switch to week, or to month, I immediately get the values about the production and the consumption of the voltaic system. So historical comparison could be a reason. Anomaly detection and alerting, absolutely. But what I see more and more is predictive analytics. So that means that we want to have information to value an upcoming event, for example. And last but not least, reporting, where time is a meaningful access for viewing or analyzing data. These are the main concepts of what are time series. Sorry, I was not in the. So okay. So what makes time series special from other databases? What I think most important thing is that we could have high number of simultaneously transactions. For example, if you think of the stock market or on the high frequency trading systems in banks, all these information will come in milliseconds or maybe in seconds, or if we could see from the voltaic what I've shown you, this will come every 10 seconds. Another typical scenario, what we see here is when you see the skyscrapers in Frankfurt, there is one special skyscraper here in Germany, which is from the Commerzbank, and they don't have an air condition in their offices. What they have is in between, they have trees standing, and with opening and closing windows, they could calculate, or they will calculate, and they will manage the temperatures in all the offices. What they need to have for is some measures about humidity and temperature and how the sun is shining on the windows. All this information will go into a big database. And from this information, the tower will control how they should open the window. It's a fantastic system. And the key point here is that we have fast growing data. And because think about this, in every single office, we will have at least 2 sensors, at least. So if they have 56 floors and every single floor will have 40 or 50 offices, you can think about how many sensors we have. And all these data are coming in seconds. Every second, there will come hundreds of information and pushing into the database server. Another thing what makes time series very special from other databases is that the same query patterns for finding data will be used. Mostly you can see time series, for example, for charts, for BI reports where you have some charts in it, and this will always be the same query. The only thing what might change is the bucket of time what you want to aggregate. For example, you say, give me a chart which will show me the last 5 minutes and give it in every 1 minute, or give me 15 minutes in every 5-minute buckets, and so on and so on. So the grouping of data by time intervals, that's the typical thing. And mainly query of current values. So what we need to have is the hot data, which is the actual data, and the old data can be stored anywhere. The big question what was coming up was when I was dealing with the first project with time series data was what database systems are available for time series. What we have is we have different database systems. You all know Azure SQL DB and managed instance and on-prem, that's SQL Server. But to be honest, I would try, if you don't have SQL 2022, prove your queries. It could be that it's using lots of resources which you are not aware of. I will show it later on. One of the applications which I mostly used is Postgres. I was very, very astonished about when I heard it, because Postgres, I was only thinking of a relational database. What comes up with Postgres was there's a vendor who has TimeScale, has developed TimeScale DB. TimeScale DB is an extension for Postgres. So if you know Postgres, you will know that you can extend your Postgres functionality with so-called extensions. And one of them is TimeScale DB, and that's an incredible fast system. To be honest, it's a little bit faster. It's faster than SQL 2022. It gets offered as platform as a service, and it's an absolutely optimized system for time series data. This is completely focused only on time series data. It can only be loaded with extension, so that means that you have to have the extension, but very simple, download it and create it in your database, and then you have it. And all the management is completely done by the extension. Absolutely super, super cool. Another way how we can deal with time series is Azure storage accounts. So that means that we put text files or anything, JSON or anything on the on blob storages. But the problem is that we do not have any optimization for queries. I do not know data lake. I have no idea about that. But I think in the cloud, when it comes to data, I quite often hear data lake, and maybe you are way more familiar with this as I am. The Azure Data Explorer was a feature to you that it was optimized for time series data, but the problem was, as I heard, I never used it, it was not the cheap way to query time series data. And then we have two excerpts here, the InfluxDB and OpenTSB. These are database systems which are dedicated to system for time series data. So that means the whole stack is completely focused on time series data. The problem with these both, with Influx and with TSDB, is that it is not available as platform as a service, not yet, and you need to have virtual machines. So you can run it in the cloud, but you are responsible for the machines by yourself. You cannot use it as a platform as a service, unfortunately, but they are pretty cool. If you want to hear more about it, how it will work, how it is optimized for time series, there are sessions in YouTube from Gianluca. It's Spaghetti DBA. I can really recommend to have a look for this. I think he did it, I'm not sure, in SQL Bits. So now, okay, Microsoft wants to have this feature too, because all of them have it. What did Microsoft SQL Server do, or what can we do, or could we do before it was SQL 2022? The biggest problem for us is that we are dealing in SQL Server with relational tables. So SQL Server is an RDBMS, a relational database management system. So it requires more, that's more something which is focused on data warehouse systems and on OLTP systems. So what can we do? In SQL Server, we have, when it comes to relational databases, we have two things what we can do to improve working with time series. The first one is index and compression. Index compression means that we put the data on less storage. We compress the data, but only, unfortunately, only on the storage. When it comes to loading the data into memory, we need to uncompress it and put it uncompressed in the memory. So there is not real benefit from the operational data. The second thing what you can do is partitioning. And yes, partitioning can do a lot for you, especially when it comes to high transactional systems. You can spread your workload with the correct design over all the partitions that you can write simultaneously on all partitions to get a little bit more speed when saving the data in your table. And for historical data, I would strongly recommend you have your data with column store indexes, because column store indexes will compress the data on the physical way, so on the storage. But here comes a good point. The compressed data are also available compressed in memory. So the memory footprint, when it comes to column store indexes, is way more efficient than it comes with index compression. But there is a drawback. You know, whenever you have some very cool stuff or some very cool features, there must be a pitfall, and that is slow with inserting data. So because why? Very short, because the topic is not today column store, but what SQL Server will do is when it comes to insert data into column store index, SQL Server will not push them into the compressed row groups of a column store index. What we're using a delta store, and the delta store is a typical heap structure, which is not compressed. There's nothing with that. And when you have high transactional data, it could be that the compression of the delta stores is too slow, that it will grow up and more and more and more. We had one customer with this problem. But the good thing is that we could have high compression. And the last thing what we can use and what will be used heavily with when it comes to time series in SQL Server is index views. An index view does mean that we put the aggregation into a view, putting an index on it, and then we are querying not the table itself, but we are taking under the hood the compressed indexed views. The biggest problems with index views is that the update, when the update will happen in the table, it requires to update the index views too. That could slow down your system. So you always need to find a balance, whether you would like to have a performant insert process or you want to have quick data in your reports. That depends on the workload of the application. So what can Microsoft SQL Server do for you? Time series is often used for historical comparison, anomaly detection, and so on. That's what I was telling you. And time series capabilities in SQL Server have been introduced first with Azure SQL Edge. But then with SQL 2022, Microsoft has implemented new features for dealing or for having better and more performant queries when it comes to time series. A few of them you would say, what does it have to do with the time series? But for example, generate series is a great feature which create numbers, but you can use this in conjunction with date bucket or date trunk to generate a list of dates which you want to run queries against, for example, for a join. For me, the biggest highlight ever is the date bucket and date trunk function. These both are working a little bit similar, but they both have another big, cool improvement, which I've never seen before, and I really love it. And I will show it in a demo what the problem is when you are dealing with 2022 and with 2019 or older and what has been improved. Well, we have the first and last value, very simple. Give me the first, give me the last, but from the ordering. And these are new function or functionality what we will have in SQL Server since SQL 2022. What is the general problem with time series? We need to understand what we are doing with time series. Time series get often aggregated. This is the key point for using time series. Give me the average temperature over a period. Give me the max temperature. For controlling it, do I need to cool it down and so on, and the min. And when we do this, when we are working with aggregations, then SQL Server must use for the execution of the query so-called aggregation operators. And for the aggregation operators, we have two of them in this for the SQL query optimizer. The first one is the hash aggregation, and the second one is the stream aggregation. The hash aggregation is the bad guy here. So whenever it comes to aggregations, the hash aggregation, we want to avoid it. This is when we are working with time series. When it comes to lots of data, we definitely want to avoid hash aggregation. Why? Hash aggregation is mostly seen because there is no predictable sort order for the converted time value. I show it in the demo, which after this slide deck. And here comes the biggest problem. Hash aggregation is a so-called stop operator. A stop operator does mean very simple, very primitive. The operator is collecting the data, which is coming in from the previous operator, and it does not forward the data before all the data have been processed. And that's a stop operator. A typical stop operator, what you will see is in every single query is a sort operator. Sorting does mean that whenever we say an order by, when it's not indexed, SQL Server need to collect all the data, do this ordering, and when the last record is in and it has been ordered, then we can push the data to the next operator. All of these stop operators must use memory for the sort operation. So let me show you what I mean, and let me show you what the problem is. So as I said, if you want to download it, no problem. I will have the link at the end of the presentation. General problem, here we are. So I have prepared everything because creating big tables here does not really make sense because that is too time consuming. I have a demo DB and I have here a table with around 5 million rows in it. It's from 2018 to 2019, just only 2 rows. This here is for orders, but the problem is exactly the same. Here, we will have a time series the same way. It's called order date. And let me show you the problem. By the way, you will see in all of these queries that I'm using maxstop. Please notice that I only use this to simplify the execution plan of the query because I don't want to go in parallel that because I want to focus on the real problem, but not on, hey, here's a parallel plan and this, blah, blah, blah. I just only want to focus on the problems. Here is my first query. What I have, and that's quite important, I have an index on the order date. So the first query, first of all, to understand how I would love to see this is that I say, please give me by every single date the number of orders. Due to the fact that I have an index on the order date, it will automatically use an index seek. Here it is. So the 1st of January, I have 6,000 orders and so on. Let's have a look to the execution plan. And what you can see here is exactly what I want. What SQL Server is doing here, I enlarge it a little bit. I use the index seek because I have here the range from 1st of January 2019 for just 1 year. And if you look to the properties of the index, you can see in the last part that we have a seek predicate on the order date, which is bigger or equal and lower than. Perfect. Then we come back with in total found 1.32 million rows in it. And now see what SQL Server is doing. We want to have an aggregation. The aggregation is here my count operator, count big. I'm using count big because the stream aggregate is always returning a big int. So that prevents me to using another convert implicit. So here is my stream aggregation. And the stream aggregation can be used because for one simple reason. The data coming ordered by the order date to this aggregation operator. And what is the result? We are coming back with a few rows only because of the aggregation. But have a look to this. Look to the select statement and you won't see any memory grants. So what I always say when I'm doing this as a workshop, I tell the people, think big. Think about this. Let's say you are a company which are implementing solar on the rooftops. And you have, let's say, 500,000 customers. I promise you, there are lots of customers like me who are every single time looking, hey, how much do I produce now? And how much did I earn? And so on. And now think what happens if this kind of query will be executed 1 million times a day. Here, this one, we can completely relax. We say, oh, come on. Well, we do not need any more resources, just only scan through the index, come back with a few million rows, and then we do the aggregation. And the stream aggregation is something like, because SQL Server trusts the index, it's saying, well, okay, it is ordered, no problem. The next, and we're pushing it forward. What SQL Server here is doing, it is counting the data while they passing the aggregate. So that is the reason. And due to the fact that SQL Server trusts the index, it definitely knows when the 1st of January stops, we put the number of counts and we then start with the next one. Oh, well, the first is finished. There is another one from the second one. We reset and 1 and 2 and 3 and 4. Absolutely perfect. This is what we want to have. But unfortunately, the typical queries for time series is not like this. The typical queries for time series is exactly this here. For example, we want to have an aggregation, but for a dedicated bucket. Because when your customer is saying, yeah, I want to see how much kilowatt I have produced, but show it in, for example, 5-minute buckets, or show it in 15-minute buckets, and so on, and so on, and so on. What we then have to do is we must then transform the original date into these kind of buckets. And this is what I'm doing here. I know it's a very rough bucket because it's a full year, but this is what I want to have here. I say, okay, give me per year, per month. This is my bucket, the smallest bucket. Give me the number of orders. I run this query just only for 1 year. I run this query, and now you will see what happens here. It takes a little bit. It's okay. So now in 2019, in January, I have this number of rows. Perfect, very fine. It looks good. And what I see is, I think it was running cool, but I have to have a look to this. Yes, it looks very cool. We have just only 1,900 logical reads. This is cool, but this one makes me a little bit nervous here because now I see that I have created a work table which is in TempDB. The query was running in 962 milliseconds, and what I see is lots of CPU. And now again, we're thinking big. Let's say this query is running 1 million times a day. What is going on here? Why is it so expensive? Because I think it's a simple aggregation. And here you see the problem. Again, we are coming with 1.3 million rows. And by the way, SQL Server normally would do this in parallel because of the high costs. So we are coming back here with 1.3 million rows. And what you see then is this. The compute scalar operator is an operator which is transforming data from one status into another. You will see it all the time when you run a query where you can see where you're transforming data like is null, year, month. All these are transformations. And then SQL Server will use this one. Let me show you what it's doing here. You can see it that SQL Server is saying, well, okay, I need to have the date part, the year from the orders. This is for my year function, what I'm using here. And the same is with the date part month. So what SQL Server is doing, very simple, internally, it's using the date part function while we have new functions called year and month. Very simple. But now think about this. The data are coming ordered because the order date is an index, and you can see it here. If you have a look to the second last row, there is something like ordered, and you can see it is true. So the data are just coming ordered to the next operator. Everything seems so far okay, but now SQL Server transformed the data, and in the moment we transform the data, now SQL Server has a problem because now we do not have any predictable statement that the data will definitely come ordered to the next operator. So it could be, but SQL Server do not know it. I think normally you would say, oh, come on, this is not possible because when the data are coming ordered, we can definitely rely on the ordering in the same way when the data gets out, when we get it to the next operator. That's true, but that's what we are thinking. But there is no guarantee for SQL Server. And whenever SQL Server will not have any guarantees for any operation, it tries to cover it with other operators. And this is the hash aggregation. What is a hash aggregation doing? Well, very simple. Unfortunately, SQL Server is creating in memory for every single value a hash bucket, and then while the data are coming, so for year and for month we have the hash bucket, then we have to throw them into these buckets. Afterwards, we count them, and then we get the data back to the next, push it forward to the next operator, which is the sort operator. The sort here is only because of this here, because of the order by. I wanted to have the data in an ordered way. And see what happens. SQL Server now has a problem on the select operator. It tells me, hey, come on, there is something what's going really pretty weird. And what is it here? SQL Server has to use the hash match operator. This is one problem. The hash match operator needs memory. The second one is the sort operator. So Microsoft needed to calculate for the hash and for the sort and see what SQL Server has estimated how much memory it wants to use. And SQL Server is telling me, well, sorry, I wanted to have 68 megabytes of RAM. Wow, 68. But it's okay when I think about that we were coming back with 231 buckets where we need to need to transfer the data from the index into. But SQL Server say, oh, sorry, I have a problem because I was thinking that there were much more data were coming. And so the 68 megabytes get used, but we only need it. So it would be better to have only 1 megabyte. The reason behind is a different one, but keep in mind that SQL Server has now a wrong estimate for the memory. If you do not have Enterprise Edition and you do not have SQL Server 2019, at least 2019, you won't have the row mode memory grant feedback option. That's an enterprise feature. And that means if it's going really worse, every single time this query is running, it wants to have 68 megabytes of RAM. Super. Now think 1,000 people are just querying your server. Hey, and they all want to have 68 megabytes. I think that will be lots of fun for you if you're a DBA. So what can we do? Let's try to do it. Let me check this. What we can do is we can use or we can force SQL Server when it comes to time series to say, hey, I want to have the groupings. The groups are the year and the month. Please order them. Force it to order the data to push them to the next operator. But I think you all will know what's going on now. When we say we want to force the order, then SQL Server is required to have a sort operation. So now when we read the execution plan, we can definitely see, oh my goodness, we are coming with 1.3 million rows, each one with 10 bytes of average row size. So then we are now creating the year and the month, and we are coming back with 1.3 million rows, and they need to be sorted. They need to get ordered. And I hope you know the sort operator cannot scale. As more rows you will have, as longer it will take. We have no possibility to improve it. Yeah? So now we are coming with the exactly 1.3 million rows. We come to the through the stream aggregate, and now we are pushing the data by okay, that's the first of 1, 2, 3, 4, 5, and wait, and so on. And here's the select. Have a look to the memory grant. I think it was not a good idea. Sometimes we can see, and we can prove it by evidence, that the guys at Microsoft are doing a good job when it comes for queries. So you see, when we want to force extreme aggregate, we need to force order book costs not eliminated. We just push them nearer to the total amount of rows what we want to process. Not a good idea. So then I thought, how can we improve this? And the idea was to pre-calculate. This here is exactly the same query, just only with, let's say, other technique. What I'm doing is I push the order date, because that is the problem here. We are doing here the year and the month outside in the select statement. Why not do it earlier? So maybe you know, from is the first what gets executed. From where, let me think, from where a group by, and having select order by. This is the typical way how queries gets executed. So my idea now is, why do we not push the order date into a cross supply, that the binding or the transformation of the values what we want to have are not happening in the select, but they are happening in the from part, which is the very, very first part. This is what happens first. So then the idea is that now we could improve it, and let's gonna check it. Maybe SQL Server is such smart that we can use it this way. Execute. Oh yeah, it seems to be. It was a little bit quicker, but have a look now. So SQL Server say, no, no problem. We have the compute schema, which makes the transformation. And then we're pushing the transformed data to the hash match. So whatever we do before 2022, and before using the right function, there is no way for it. Might be that there is no way to do this. So what can we do? What did we do before SQL 22? The key point was, and this is something what we cannot do all the time. See what I'm doing. I take my orders table now, and what I'm doing is I'm creating two calculated columns. These two, and let me do this because it takes a little time. I create them, and then I create an index on these calculated columns. That's what I'm doing. So what will happen now? I will take exactly the same query as before, but here you can see how smart the SQL Server is. But to be honest, if you have a vendor software or someone has created the data warehouse for you where you run the queries against, it might be that you are not allowed to do it. So here is my query. What I'm doing now is I say, give me the orders, give me just only for 2019, and do an order by and see what SQL Server now is doing. Execute. Here we are. And you see that we now have the stream aggregation. So that means for us that we do not have any more memory grants. The compute scala is fine here because of the count. That's okay. But let's see if SQL Server is as smart as we think when we take the original query and want to run exactly the original query. Because here you see that we have the transformation always in the code. So let me go for this. 1 second. Execute. And what I want to see is that SQL Server understand this, but oops, unfortunately not. So we are doing the transformation and it's not working this way. So what we need to address here is that we address the columns where we have put the index on it. So, but as I said, it is not always possible to do that. Maybe you have a vendor-driven software and the vendor-driven software does not allow this to you. I dropped the index and I dropped the additional columns on it. We are now back to the original one. And here comes the ultimate way how we dealt with that before 2022. Because what we did is we create a index view. So here we have the orders by year and months, and you see that we have the aggregation in it. If we would run this without any more additional indexes, it will behave as before. But what I do now is I now create a unique clustered index on it. It must be a unique index. The biggest problems with views, with index views, is there are too much regulations for this. It must be, you must have a clustered index. You cannot use, I think it's average, not sure, because it gets calculated by count. You can use different formulas for this. It's all not the easiest way. So now, when I run again this query, you see that I do not address my my view. And even whether I'm using it or not, SQL Server is using the view. But this, so not to change it, is an enterprise feature. Yeah, so that SQL Server detects, hey, I'm accessing the orders table, but then it sees, hey, I have a view which is exactly the same here, and go to the index of the view. This is an enterprise feature. You have to pay for this. So, but then SQL 2022 was coming. And here is the game changer for this, exactly for this problem. I will go into detail what this function, this magic function will do. First of all, let's have a look to the query. I again do some aggregations. I want to have the year and the months of a from my orders, and I want to count the number of orders. That is fine. This is exactly that what we wanted to have. I access my orders, but then what I'm doing is I'm transforming data. Transforming data again. Yeah, it's the same as when I say, give me the month, give me the year. No problem. I'm transforming data. Because what I'm doing now is I want to have the month value of the order date. As I said, I come in a few minutes to this, how it works. This is the cross apply. So we invoke the order date, it gets transformed, and with this way, this one, I get into the final transformation. See what happens here. There is no additional index, there is no magic in it. Oh, come on, it's for all. And see this. You see here that we now have no more hash aggregation. And what is the reason for this? The reason is very simple. And I think maybe by accident, but I'm not sure. I cannot prove it by accident, by evidence. The date bucket function is considering the index. So that means that when we do the compute scholar, then SQL Server trusts the function, the conversion, that it will come in an ordered way. And that makes the system, let's say, way more performant, because now we are not dealing with too much memory. The memory, by the way, what you see here for the sort is just only for order by. And SQL Server thinks we need what 65. I need to check it later on. Oh, I'm not yet here, but what the heck is going on? Stream aggregate. Yeah, there is something weird going on. I need to check for stop. Yeah, it's the same query. No, it's not the same query. Let me check it once again. Want to check whether it's just adjusting. I need to check why it is. That is completely nonsense here. The 65 megabytes, because for one simple reason. We know that after the aggregation, SQL Server is thinking that there are just only 20 rows, 578 rows coming back. Sorry for this one. I cannot explain why, but the key point here is, first of all, that SQL Server now trusts the transformation that it will come in the order of the index. And so SQL Server do not need any more the hash aggregation, but it can use the stream aggregation. And this is the evidence that SQL Server trusts the index data. And then it goes through the rest of it. And normally, I do not know why, but normally without requesting so much memory. Do you have any questions so far?
There is no questions in the chat, but they might happen if we ask for them. So
yeah, but then I will go on, or if someone has a question, absolutely no problem, but maybe then afterwards.
Yeah.
Okay, so this is the general problem with time series, what we had to deal with. And you might think, oh no, I'm doing it all the day and I don't have this problem. Watch it. If you just run Query Store, put it on. I always would recommend to put it on and check your most expensive queries when it comes to TempDB, for example. So What is now when it comes to aggregations, the most of the time when we want to run aggregations, we want to have them in buckets. This is the key component, and therefore the common solution for using this was CTEs. Let me show you what I mean. For example, what I want to have now is a bucket for every 5 minutes. And then for every 5 minutes, I create a bucket and want to have, for example, the average temperature for a dedicated sensor for a city or anything like this. And the key point was, how could we create the so-called bucket list? And we did it normally with common table expressions, with recursive common table expressions, where we say here, you can see this. I say I have a start date, the 1st of January 2021, and then I add 5 minutes to this as an end date. So now I have for this bucket the start and the end. The only thing what I'm doing then is I take this and then I go through it in a loop with the result and add another 5 minutes till I'm at the last date. We did this for a stock or for stock monitoring, that someone was looking for a stock value, and then we saw always, let's say, the last 15 minutes, and they could switch with buttons to say, give it in 30-second interval, in 1 minute interval, and so on. And they must be very, very quick. If you have worked with traders, you know what I'm speaking of. So let me show you how this worked. Let me close this one. Yes, please. So querying time series. Here comes the query. Let's check this out. I need to go into my demo database. Everything is prepared. And here we are. I have a table called weather data. The table weather data has, in the original size, over 600 million rows. And I have these kind of columns here. And what you can see is the primary key is on the city name and then on the time. I didn't do this on the time first for whatever reason. I just want to show you how the solutions, how we can create buckets. And on top of it, I want to run the aggregation on the temp-C, which is the temperature in Celsius. Here I have my indexes, and you can see I just only have the primary key, which is on the city and then on the time. Here is my first query. What I see here, I want to have, for example, the average temperature for any city, for every city per year. So this means that we go through the whole table, and you can see that it will take a little bit of time, or a lot of time, depends. So I don't want to run the query all the time again. But think about this. This is a query which is not dedicated to run, for example, for a monitoring report or something like this, because that will take much too long. It was taking 10 seconds. So now I see for every single city name, I see the year, and then I see the average temperature. This is my I/O. You see that the SQL Server is going in parallel, and it took 70,000 I/Os. And look to the CPU. It was 34 seconds of CPU burning down my machine. I'm sweating. And the elapsed time is around 10 seconds. Fine. Look to the execution plan, and you see again the problem, what I've discussed earlier. We made a transformation. We want to have the year. SQL Server cannot trust the index. So what we are doing is we are here with this demo data. We're coming with 17 million rows, and then we aggregate them, calculating them, ordering them, and pushing them out. And this is what SQL Server wanted to have for the memory grant, 90 max. So far, so good. But what we were doing here is that we are consuming lots of CPU, And the reason for this is that we were going in parallel. You see here that I go with 8 cores going in parallel. And this is the reason why it goes so far, so quick. So again, I don't want to do this here because you know the result. Oh, we are a little bit late. You know the result. Whether I'm doing it with an injection of the time with a cross supply, it doesn't work here. So we can go to the next one. If no pre-ordering, you can use it with the order group. It does not work. How will this kind of query perform? And this is what we want to do. And I've tested it with column store. It's not here in this database. Let me see. I don't think so. No. And what I checked is with partitioning. So it all does not perform well because of the memory request. And so I came to the idea and said, well, why not going and working with CTEs? So what I'm doing here is a very primitive thing. I want to have the last timestamp for New York, and then I go 15 minutes back and want to see the average temperature or the max temperature within the last 15 minutes. So I run this query, go to the execution plan, and what you see here is that now, okay, it's very simple. We just only have, we want to see everything what is 15 minutes back, and we don't need an aggregation. The only aggregation what happens is the max here. But this one is very simple because what SQL Server is doing, it's going with the seek in the index, using the top one, and that's the aggregation because we know that's just only one record. And then we go into the index and we are finding for New York the last 15 minutes. That is a good approach so far, but that's not the typical way how we want to run queries against time series. Normally it's like this. We give a start and we give an end date because for analysis. And here we come to a point where we say, that looks a little bit different. Here I have limited the number of data just for one single hour. And my interval is 15 minutes. So what I expect now to see is a bucket list of 4. So it starts at 0, goes to 0.15, from 0.15 to 0.30, and so on. Let me show you first, before I run the query, how it looks like. Just only to see the result, that you can see what the result of this one will be. And you can see here, oops, I do not know why, but it's okay, it doesn't matter. So what you see here is that now I have a start date and I have an end date. So from 0 to 0.15, from 15 to 30, and so on and so on. So that's what the CTE will bring back. And what I'm doing then is I'm joining them. I take the bucket list what I have here, and then I join them with the weather data, and I'm running the query for Austin so that I will want to have 4 rows getting back. And I run this query and see how quick this is. Action, and here we are. So now I can now change when I think of a stored procedure for a report or for a Power BI dashboard, that now someone will change the interval. I can just change it and automatically say, I want to have it in 5-minute buckets. I just change it to 5. And when I run the query again, I now get not 4 rows, now I get 12. Because now I have the 5-minute buckets here. Just only by changing the interval, that's it. And this is what we want to have. But you see the effort, what I have to do. I need to create my temporary bucket list by the intervals, and then I need to join them to get the results back. So here is another thing. Let's check this. This is, let me see what I want to do here. Yeah, by city name, I want to have the average. I checked it with a cross apply. I can promise you, I don't want to run this here, but I can promise you there is no improvement in it. SQL Server is way too smart for it because a cross apply is internally nothing else but it behaves like an inner join. So now I checked it with the column store. I just jump over it with the column store. I don't want to check it with column store. The best way is to use index views. Yes, can be done. But you see, or I've seen that index views are not always the best. So then what we can do is when it comes to SQL 2022, strong recommendation, forget all of this. You don't need it anymore. There is a function, it's called date bucket. The date bucket function is pretty cool. So we have two functions, what I think, please allow me to have another 5 or 10 minutes, please.
That's fine, Uwe.
Yeah,
go ahead.
Okay. The most important thing to work with bucket lists is, whether you know it or not, the generate series, because you can create with generate series your bucket list very, very simple, very easy. Generate series is new in SQL 22. Maybe a few of you have this famous function from Itzik Ben-Gan, where he can generate billions of rows in milliseconds. And the generate series is the same, is working the same. We can generate a list. So what I'm doing is very simple, just only to demo you how it works. I go into my demo database, and how does this work? The generate series, first of all, the generate series is a table valued function. It always returns a table. And when it comes to the table here, let me do this. I define the start value. So what is the initial value to start with? The maximum value, and the interval. So here I say I want a numbered list from 1 to 100 and with an increment of 1. I execute this query. So here we are. That's very quick. We have the 100 rows. When I look into the execution plan, you can see here that this is the table valued function, and the estimate seems to be pretty cool. Let's check whether I take 1,000 rows. Because that is one of the problems with table valued function normally. And you can see SQL Server always know the number of rows coming back. What will happen if we say it only must be 500, because the interval is 2? So that must be 500 rows, but no problem, I think, for SQL Server, yes. Because we know the start value, we know the end value, and because of the interval, it's a primitive math. Yeah, put the end, reduce it by the start, and divide it by the interval. That's it. And so SQL Server always will know how many rows we will get back. But you must be careful with this. If you want to use generate series, you must be aware of the data types. Look to this. We say here, I want from the generate series, my starting value is 0. I want to go to 100, and I go in steps or in intervals from 5.0. It seems to be, say, oh, come on, well, no problem, but it is. When I run this query, I get an error. Because what SQL Server is telling me, sorry, when you want to use generate series, please make sure that the interval and the increment will have the same data type. So what does this mean for us? You see here the interval and the end date and they all must have the same data type. You cannot mix them. Now it's working. Now we don't get any more problems. But the good thing, the cool thing with the generate series is the working with the generate series and the date bucket function. The date bucket function, I come to this, is something like this. I say, for example, here, I want to generate 100 dates with an interval of 5 minutes. So what I'm doing is I generate my series. I say, okay, please start from 0, go with 100 rows, interval is 5. What I'm then doing is with this return value from the generate series, I'm invoking it into the cross-apply function and say, please add minutes, the value from the generate series, to my actual date. So what will happen now? Now I get immediately a list of the next 121 rows, sorry, for the date bucket, yes, and in intervals of 5 minutes. And trust me, this is way faster than working with the CTE because it's all included, that's all internal functions. This is absolutely super. Here is another one. I go now with 15 minutes. Yeah, it's minute. So here we are. And now we have the same period, but now in 15-minute buckets. And we can now work with this. We can run the queries on the Timeseries database with this. And you can use whatever bucket you want to have. So the date bucket function can use day, week, month, quarter, year, and hour, minute, second, and even millisecond. You can create buckets in milliseconds, and you can see how detailed it is. So here I have it with a week. So now I get the values, and what you see here is this is the value from the date series, and what I see here with the week is I start now. That the get date here. And what I'm doing now is I say, okay, the actual date, because I need to add them. The next week starts, let me have a look, at the 12th, the next one on the 19th, 26th, and so on and so on. I absolutely love this feature, the work, how they work together. So the date series, the generate series and the date bucket. Now let's come to the last point, the date bucket, because I love this feature. Date bucket, you have seen SQL Server now trust the return values of the date bucket from the perspective of the ordering. So SQL Server knows that the date bucket will return the data relying on the index. For me, the one and only big thing. Then the date bucket function requires at least 3 values. The first one is the date part. So what is the size of the bucket? Do you want to have it in minutes? Do you want to have it in weeks? And so on. And so that is the grouping, let's say. And we can, as I said, have days, week, month, quarter, all the date parts, what you know from other functions. The second one is the number. The number is the size of the groups or the width of the group of the bucket combined with the date part argument. For example, if I say I want to have a 2-week bucket, then you need to say, okay, the date part is week and the number is 2. So then you get a bucket for every single 14 days. And afterwards, we need to have the date. The date bucket will accept a column expression. We can use a select statement. And the only thing what is important is that it is a valid date, date time too. All date data types can be used. So the working with this is very, very simple. So you see here my query, what I wanted to run is it allows to arrange data into groups, the buckets that represent fixed intervals of time. And the good thing here is it returns the datetime value that corresponds to the start of each datetime bucket. What does this mean? Well, it could be that I say, let me just switch over here. I say I want to have a date. I don't want to have date time. And you see what the output is? SQL Server returns exactly the format or the data type of the parameter of the date. And this is a very cool thing. The second thing, date trunk, by the way, is working nearby the same. It respects the index, it returned the data index, SQL Server recognized the index. The only difference here is that we use a date and we can extract the part out of it. Let me show this, and then I think we're finished. So here is my date bucket function. Let me show you how it works. You remember, you define the bucket, and then you define the size of the bucket. And here is my starting date, the 29th of June. And let me do this with the 4th of July. So 15. So what I'm doing now is I'm just only running a query with different buckets. And what you now see is what week it belongs to. This is the 4th of July. And you see that the week we're starting for this day, it was starting on Monday, and that was the beginning date, or the 1st of. So when I give 2 weeks, yes, it is the 1st of. And then you see that it goes back 3 weeks. And the reason for that is the origin date. The origin date starts when you never enter it at the 1st of January 1900. That is the only little complicated thing. And what SQL Server then will do, it creates here for the number 3 buckets of 3 weeks. So we start at the 1st of January, 3 weeks. Then we go to the next 3 weeks and 3 weeks and 3 weeks. So it could be that the 4th of July is not in the very next one, but it started at the 24th. That is the group of the 3 weeks which started at the 24th. This is how the date bucket function is working. So now let's see how this can work. What you see here is I am creating for every single time here from the 1st of January for just only a few minutes, 15 minutes, because otherwise it would take too long time. We start this and see what SQL. Oh, sorry. Yes. I always tell in my workshops, you have to make sure that you are in your database. Always use database. So here you see the original time. And here you see what SQL Server is doing with the date bucket out of it. So date bucket creates only the bucket border. Aggregation is not included. It's saying, okay, this value belongs to this group. This value belongs into this group. And what you can see now is when we go on, it's all the same. It's in the group because we want to have hours. We say it's all for the hour 11 p.m. So because here we are at 11. So when we switch over, here we are. Look to this. So now we say this is the last timestamp which belongs into this bucket. When the next one is coming, then SQL Server starts a new bucket. That's how date bucket is working. And you can aggregate them. This is what we want to do. Here we go with 15 minutes. And the 15 minutes, let me see, this bucket's in 15 minutes, in an interval of 15. And you see here, whatever I take, you see that this one starts with 11:45 until we come to midnight here, we start with the next 15 minutes. And these are the buckets. And the next one is at 0:15. Keep in mind, the date bucket function is always calculating the minimum value, the start value of the bucket. And here is, for example, a query where I say, please give me the per year and per month, the number of measures, the average temperature. Oh, that will take a little bit to, let's see how fast this is. It is. I execute this, and that was quick. And SQL Server is aggregating it, so it's pushing the 21 data, and I say date bucket year. So that means that every single time row, what we have for New York or for every other city, is all which is greater than the 1st of January 21 is automatically assigned to this bucket. If we would have data for 2022, then SQL Server will create the new bucket and will push all the information into this one. And you see it perfectly here. We have 168,000 measures in 2021, and the average temperature is 6 degrees. So this is a typical query. Let me check this. We are working here with date from parts. You know, this cannot scale. Let's go and check it. I want to see which one is faster. It's exactly the same. 1, 2, 3. Here comes the first one for New York for all years, and then it comes the second one. And what I want to see is, oh shit, I want to see that the last demo, I forgot this. Sorry for this, guys. So here we go. I run both. No, I just run one, right? Yeah. Okay. Now I run both. Last time, all good things are 3. So the first one and the second one, and let's see how it works. This is the first one. It was running 3 seconds, but you see that it was taking 1 second hooked on the CPU, working on it. And here is, oh, this is not good, right? And this is demo. Because I have everything running behind, I have my teams behind me. This should be normally half of it, around about half of it, and the elapsed time should be around 2 seconds. It depends on the mood of my laptop, because when I have everything here on it, it's sometimes the reason that it's a little bit slow. But you can trust me, normally the date bucket function is way, way faster because it is not calculating, aggregating with a hash aggregation. So this it was. I thank you so much for being here and to present to you the time series, current time series. I hope you enjoyed so far what I did. And if you have any question, then yeah, I am open for questions now.
Thank you so much, Uwe. And even though the demo ghost once again showed up, it is
tiny little
highly
things.
it is highly mind-boggling that you need to think so much about how you structure your queries in order to get a good performance on time series, even though in the SQL Server. So
yeah. It's so the resources which get used, you don't see when you're not regularly have a look to the execution plan. So you just only run the query. That's a typical thing for a developer. Just run the query, say, well, yeah, it's running fine, and then it's deploying it to the Power BI dashboard or to the reporting service dashboard, what else? And then they are running into problems. Yeah.
Yes, exactly. So thank you, Uwe. And on the there's one from Thomas. Do you know Thomas?
Yeah.
Yeah.
I see it. Yeah.
Thank you for attending, Thomas. That was great. Thank you. If you have any questions on this last minute, then please write them now in the chat, or else I will say a huge amount of thank you to you, Uwe.
Yeah.
At least I learned a lot here because I have worked with the SQL Server for a long time, but not in this specific date time series way. So
yeah, you need to have a project with this, otherwise I would not ever deal with it.
Exactly. When I work with date times, I always use the real-time intelligence in Fabric or the Azure Data Explorer.
Yeah. Absolutely.
Then I don't have to think; it just works out of the box. So
yeah, that's the point.
Yeah.
You don't have to take care about it.
No, exactly. It just works out of the box. So I don't think there is any questions in the chat. So highly thank you to everyone. Have a great day, evening, night, wherever you are in the world. And Uwe, once again, thank you for attending. Thank you for.
Thank you for being your guest and for hosting my session. Have a good time to all of you. Wonderful day to wherever you are in the world. I think most of you are coming from Denmark. And I would say tusen tak, whatever you say. I do not know.
Oh, great.
Yeah.
Perfect.
It's from Norway. Okay. See you. And thank you for being your guest. Bye-bye.
Bye.